Hi, my name is Marcel, and in this video we are going to solve a problem from air density. In this problem we are asked to find how high would the atmosphere be, supposing that the air density is uniform. So in this diagram we can see we have here the ground level, where H is 0, and supposing the density of air is a constant, so let's say how high would the atmosphere be? So we need to find this H2. The first thing we need to do is to take the Pascal's principle, saying that the point of the pressure P1 minus the point of the pressure P2 is equals to the integral of rho of the fluid, that in this case is the air, and times the gravity times the differential of the height. So, to solve this integral, we can said that the rho, the density is uniform, so it is a constant. So both density and gravity can be taken out of this integral, so it will be like P1 minus P2 and we have a simple integral where the result is the integral of the differential of H is H. And now we have here this formula that actually is Pascal's law. So we just need to solve for H in order to know our how high would the atmosphere be. So one important point that we need to specify is that in the point 2 is the limit of the atmosphere, so you'll have no pressure here, so P2 is equals 0. So you have P1, which actually is 1 atmosphere, and we will substitute at the end of the equation. So P1 will be we're going to solve for H. So H will be P1 minus P2 over density times gravity. And as our pressure on the point 2 is 0, this will be cancelled. And we just have here that we can now substitute that P1 is 1 atmosphere, and just to remind you, 1 atmosphere is equals to 1.013 times 10 up to the 5, and pascals. The density of the air, that is, they are giving us the value that is 1.3 kilograms times cubic meters, per cubic meter, and this times gravity, that is 9.81. And we just need to make this calculation, that we will find that H is equal to 7,940 meters. That actually can be written as 7.9 times 10 to 3 meters. And this is the solution for the part 1 of this problem. Now we are on the part 2 of this problem, and in this part we need to find how high would the atmosphere be if the air density decreases linearly to 0. So, well, we have this diagram that we had before, and now let's suppose that over here is our x-axis and here is our y-axis. It says that the density of the air is decreasing linearly to 0, so let's remind that the graph would be like this. And well, where all this is our height and all this is our density. The density is decreasing and well, the height is increasing. Well, as this is our origin, we can say that at this point y equals 0. Y not because of the y-axis, but because of the height, because y is a function of the height. And at this point y equals h. So as we can see, in the point where y equals 0, I'll put it here, y equals 0, we have that our density is our initial density. And at this point where y equals h, our density is 0 because now it is decreasing. So now what we need to do is to find an equation for this. So let's remind that, well, just as an observation, this in the y-axis we have the density, but remember that the just as to remind you, the y-axis can be rewritten as a function of x. So knowing this, now we can say that our density is a function of the height. So now we need to find our equation. Let's remind that the equation for a linear graphic is y equals m times x plus constant. Well, where y is a function of x. So now we need to put all this in terms of this. We need to find the value of a slope in order to complete the equation. So the slope is equals to, mathematically, x minus initial x over y minus initial y. And well, now we will put this in terms of this, and it will be density minus initial density over y minus initial y, but all this is our h, so so it will get something like this, and let's say that the point on the pressure on the point 2 is equals to 0. So our point 2 would be our final density. So now we can eliminate it from here, and well, this is the value of a slope, our slope. m equals minus initial density over h. And now to erase all this. Oh, sorry. I erased the equation. And now, well, we have found our slope. So let's just substitute, and it's minus initial density over h. Our x would be our y, because remember that over the x-axis we have our y's, and the constant that would be our initial density. All this would be our equation. So as you can see, it's pretty much the same. And well, what now we need to do is to integrate this to find our height. So now we have this equation, our linear equation, and well, let's remind Pascal's principle, that is 0.1 minus pressure on 0.1 minus pressure on 0.2 equals the integral of rho, which is the density, times gravity times the differential of y. Well, let's say this rho is our function of h. So now we will just substitute this in here. So this is the integral of all this, that is the initial density minus the initial density times y over h times gravity times the differential of y. And now we just need to solve this integral. And let's remind that at this point y equals 0, and at this point y equals height. And well, let's just solve this integral. I will do it a little fast. So remember that we have to multiply this. So we have initial density times gravity minus all this times gravity times the differential of y. And as you can see, all these are constants, and even this and this one are constants, so we can take them out of the equation of the integral, sorry. So we will have a initial density times gravity, the integral of dy minus the initial density times gravity over h times the differential of y, because we have it here, dy. And well, let's solve this. That is and well, as y is equals h, we can just change these values here, h and h, and this h that is dividing here cancels the square. So now all this is change here, and as you can see, well, this 1/2 I will write it here, And as you can see, we have the same terms, but we have this 1/2 that is resting. And well, let's say that 1 minus 1/2 is 1/2, and well, we can say that all this is 1/2 of the initial density times gravity times the height, and well, all this is equal to this. So P1 minus P2, but remember that the pressure on the point 2 is 0, so this is cancelled. So now we just have that P1 is equal to P1 is equals to 1 atmosphere, which is 1.013 times 10 to the 5, and we just solve for H, so H will be equals to, we have 1.013 times 10 to the 5. These two in here will go multiplying, and all this, the density, that is 1.3 times the gravity, goes dividing to the other side, and well, we just need to solve this, and we will find that our height is equals to 15,886 meters, which will be also as 15.6 would be could be rewritten as this, or as just 15.88 kilometers. So all these are our answers. So thanks for watching.